Today we're going to talk about the lab of finding the value of R and the molar volume of a gas at STP. You're going to be reacting magnesium solid with hydrochloric acid. It's going to be a single replacement reaction to make MgCl2 and H2 gas. You should have written this yourself and balanced it correctly. Since this is the gas in the reaction, this is what we're going to focus on to find R. So if we're trying to find R, we need to know every other aspect. We need to know temperature of the hydrogen, moles of the hydrogen, volume of the hydrogen, and the pressure of the hydrogen. So the first thing we have to figure out is how do we react magnesium and hydrochloric acid and capture all of this hydrogen gas in order to measure all these things. So to do that, you're going to collect the hydrogen gas over water. You learn that that's a good way to collect a gas, and so here's what you're going to do. You're going to first take a eudiometer. A eudiometer is like a giant graduated test tube. It has volume markings on it. And you're going to put about 5 milliliters of the 3 molar hydrochloric acid in there. And then you're going to fill the rest with distilled water up to the top. You're going to have a small piece of magnesium. You're going to get the mass of this magnesium first. You're going to tie a string around it, dangle the string outside the eudiometer, and then put a rubber stopper into it right here. And the rubber stopper has a hole because that's going to allow the flow of liquid outside of it. You're going to put your finger over this hole, block the hole. You're going to turn the whole thing upside down, and you're going to put it inverted in this giant cylinder of tap water. Because HCl is more dense than water, it's going to swirl down. You can actually see the swirls going down. As soon as it hits the magnesium strip, bubbles of hydrogen will form and collect at the top. You'll know the reaction is over when there are no more bubbles. So now you're going to, at the end, have a gas up here, which is the hydrogen. But remember that whenever you collect a gas over water, you're going to have water vapor also in this. And down here is just going to be the rest of the distilled water, and a bunch of this has drained out through the hole into the giant cylinder. Okay, so now the question is, how do we record all the different variables for this lab? So we could start with the temperature. It'd be easy. So you're not going to be able to get the temperature of the hydrogen by sticking a thermometer in here, but you could get the temperature by measuring this temperature right here of the water in the cylinder, because remember, all of the hydrogen bubbled through this, and so the hydrogen is at the room temperature. These liquids are at the room temperature. So you're basically measuring the room temperature, but we're going to do it in this bath. So that's going to a cylinder. It's not really a bath, but the cylinder. So that's going to take care of the temperature. Okay, so now we know the temperature. Let's talk about the moles. How are we going to know the moles of hydrogen in here? Well, you're not going to be able to measure the moles of hydrogen, but what you could do is measure the grams of magnesium in the beginning of the lab, and then change that into moles. And because this is a 1-to-1 ratio, the moles of magnesium that you used theoretically should be the same as the moles of hydrogen that you formed. So there's the moles. The volume is going to be easy because you're just going to read it off the eudiometer. The eudiometer has markings on it, and you're simply going to read the volume of the hydrogen gas that is in the eudiometer. And of course you can do that when the levels are the same of the water inside and out. So when this level of water is the same as this level of water, read the volume. Okay, last but not least, we need to figure out the pressure. That's the trickiest part of this whole thing. As we discussed in class, whenever you're trying to measure the pressure of a mystery gas like hydrogen right here, what you do is you measure the room pressure first, and the room pressure is going to be equal to the sum of these two, as long as these levels right here are the same. And then you just have to look up the vapor pressure of water, subtract that from the room pressure to get the hydrogen's pressure, and that's going to tell you the P. And now you have PV and T, and you're just going to solve for R and find out what that is. Another part 2 of this lab is to find the molar volume of a gas at STP. So to do that, you're just going to use a 2-condition problem. P1V1 over N1T1 equals P2V2 over N2T2. You're going to consider the room as condition number 1 and STP as condition number 2. So you've already measured all these things for your PIVNER. You've already measured pressure of the hydrogen, the volume of the hydrogen, the moles of the hydrogen, the temperature of the hydrogen. That's all from the lab. And then let's talk about STP. You know that the pressure at STP is 1 atmosphere. You know that the temperature at STP is 0 degrees Celsius. You're going to do this for 1 mole of a gas. And you're going to look for what is the volume at that STP, which hopefully is going to be 22.4 liters. So you're hoping this is going to be 22.4 liters. And of course, you're hoping R up here is going to be 0.0821 liters atmospheres over moles Kelvin. And then this is what you would use in your lab to find your percent error with the right answer compared to what you got in your lab.